Hello ladies and gentlemen, so today we're going to look at section 5.8, which is on graphing absolute value equations. You're going to want the note packet I gave you today, and then also your pen or pencil. So this video is going to focus on what an actual absolute value graph is going to look like, and how to use translations to graph them a lot easier. Now, if you remember when we first did absolute value graphs, we had to make a table, and then we had to figure that out. This is going to be a lot easier than plugging in numbers. Okay, so first things that we're going to want to look at is some vocabulary. So if you guys remember, the equation for an absolute value graph looks something like y equals absolute value of x. So remember, these two bars right here, that meant absolute value. Now, some things that we're going to want to keep in mind for absolute value graphs. They're always going to be in the shape of a V. Alright, and that V is going to be starting, or the tip of it, at the origin on your graph, aka 0, 0. So you're going to have a graph that looks something like this, and then it's going to start here and shoot off in both sides. It's going to look just like that. Alright, I'll show you an actual graph of y equals absolute value of x in a moment or two. Now, a translation. Translation becomes more apparent in geometry, which is the next class you'll take. So, a translation is a shift of a graph horizontally, vertically, or it can be both. Oops, forgot an H there. Both. Now, it does not change the size. Doesn't change the size or shape of whatever you're translating, and it has not been rotated. It's important that it's just translated. Now, a lot of people, you'll probably heard of this as the slide. You're sliding things around in the plane. Now, a reflection. You guys have heard of a reflection. The reflection in the mirror. It's a mirror image. So, a reflection in math, though, means we're going to reflect something across an axis. Usually that'll be the X or Y axis, and I'll show you what that's going to look like at the end of this PowerPoint today. So, very first thing, we want to describe the translation we see. So this is the actual parent function. This is the, without any changes done to it, y equals absolute value of x. Notice how it starts at 0, 0 here. And it goes up, one up, right one, up one, right one, up one, right one. Then on this side it goes up one, left one, up one, left one, up one, left one. That is always going to happen like that. Now on this side, there's a little bit of a difference. What is the biggest difference between these two graphs? It looks like it still goes up one, over one, up one, over one. But if you notice, it's down 2 units. 1, 2. That is important. So that is my change. Y equals absolute value of x minus 2 is 2 units down. Now, there is a way to be able to use these graphs and the equations to be able to pull a graph out immediately. So, vertical translations. Now, if you remember, vertical means either up or down. When there's a number added or subtracted outside the absolute value bars, your V is going to move up on the axis or down on the axis. So if I have absolute value of x plus 3, notice how the plus 3 is outside my absolute value bars here. Since I'm adding 3 to the outside, you're going to move up 3 units. So instead of starting at 0, 0, I'm going to start at 0, 3 with my graph. Same thing happens if you have a negative outside. So if I'm subtracting 3 on the outside, notice how I'm subtracting 3 on the outside. You're going to move your V 3 units down. So I'm going to always move it either up if it's positive, that number of units, or I'm going to move it down if it's negative, that number of units. So let's put this into practice here. Let's graph this second example. What is the graph of y equals absolute value of x plus 2? So now I got to think, what is this plus 2 going to do to my graph? Now, if you look back again, I'm adding a number on the outside, so I'm going to move up 3 units. So I'm going to move up the number. So I'm going to go up 2. So originally I would have started at 0, 0, but I'm going to move up 2 this time. So 1, 2. I'm going to actually start right here. Now, just like last time, we're not going to change the shape because we're just doing translations. So you're always going to want to go up 1, over 1. Put a dot, up 1, over 1, put a dot, up 1, over 1, up 1, over 1. And then also make sure you get the V. So you want to make sure you get on both sides. And then draw your V. Notice how it looks just like the absolute value parent function, but only it's been moved up 2 units. That is a vertical translation. Now, if this would have been a minus 2, I would have taken my V and moved it down 2. Now, we can't just go vertical. We can also do horizontal translations. And these are just a tiny bit tricky. So when there's a number added inside, this one's inside the absolute value bars, this will move your V either left or right. Now, pay attention to when you're going to move left and when you're going to move right. When you add a number on the inside of the absolute value bars, you're going to move left. Now, I always think of that a little counterintuitive. It's a little different. But just like I said before, if there's numbers in the parentheses or brackets, you're going to do opposite. So since I'm seeing plus 3, most of us would have said, oh, I'm going to move right. But it's in parentheses, so we need to think opposite. That's why I'm going to move left 3 units. If I'm subtracting inside, I'm going to move to the right 3 units. So if it's inside, it's opposite of what you see. So just try to make sure you make that connection that if it's inside, opposite. Otherwise, you will mess up quite a bit on these ones. So let's graph this horizontal translation. They say x plus 5. Y equals absolute value of x plus 5. So I need to figure out, am I moving left or if I'm moving right? Because I notice my number is inside the absolute value bars. So I'm going to remember it's opposite of what I think it should be. So I'm going to say, oh, it should be to the right because it's positive, right? But I know it's opposite. So I have to go to the left 5 because that's the number they gave me. So normally I would have started at 0, 0, but I'm going to move left 5 first. 1, 2, 3, 4, 5. Right about there. Now, just like last time, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, and so on and so forth on that side. And then over here, up 1 over 1, up 1 over 1, up 1 over 1, and so on and so on. And I have a perfectly translated V. Notice I don't have to make a table. I don't have to make anything. It is as simple as figuring out your translation. Now, I'm also going to take a look at reflections with you guys today. Now, reflections are pretty important. You see these quite a bit too in real life. When there's a negative in front of your absolute value bar, that's going to flip the V. So normally, you would have had an absolute value graph that looks like that, right? Now, what this is going to do with this negative right here, it's actually going to take that V and it's going to flip it so it's upside down. So it's actually going to take that V and just flip it upside down. Just like the X would be your mirror. So the V is going to be mirrored across the X-axis. That one's just a little hard, but just always remember, you're going to flip the V from what it normally would be. Instead of being a V, you're going to have a mountain. Alright? So we're going to do quite a bit of work on this tomorrow. So I'll see you later, Sabers.